So now let's talk about cryptography and tokens. This particular chapter we'll talk about, we'll explore Hashlibs, subjects like secret, HMAC, and JSON Web Tokens. So let's start talking about Hashlib. This module exposes a common interface to many different secure hash and message digest algorithms. The difference is, though, in those two terms is simply historical. Older algorithms were called digests, while the modern algorithms were called hashes. In general, a hash function is any function that can be used to map data of an arbitrary size to data of a fixed size. It's one-way type of encryption in that is not expected to be able to recover the message given its hash. There are several algorithms that can be used to calculate a hash, and so let's see how to find out which ones are supposed by our systems. Note that your results might be different than mine. So in this case it will not be necessary to create a new file, but I will use the console, like import Hashlib. Okay, it's hash like this, Hashlib. Then you can say Hashlib dot algorithms available. Okay, notice here that there are a lot of them start with SHA, which means secure hash algorithms. Let's keep going the same shell. I'll type hashlib dot algorithms warranted. Okay, it's not warranted, double E. Okay, very similar there, but try something different here. You will say 8 is a hashlib dot Blake 2D Blake. Blake 2B. Something wrong. Blake 2B. Okay. And then you will see 8 update B as now, with the message of now. First, let's say hash me there, then now you finally will execute h.x digest, and you will see something like this. That's an x digest, but you can also say h.just digest. You will see something like this. You can evaluate the size typing h.block size, or you can say also asking for the digest size. Also you can ask for the name h.name, and you will see that it's a Blake.2b. Okay, very very simple till now. Let's try another exercise. Let's see another example where we customize a hash by adding a key, a salt, and a person. All of this extra information will cause the hash to be different than the one we would get if we didn't provide them. Are crucial in adding extra security to the data handling of our system. Inside here, let's say it will be Hashlib dot Blake to v, and the first parameter will be b, important payload. Then we'll say digest size must be 16, key will be v secret key, salt will be random salt, and person will be b Frank. Okay, now you will see it's the method that we executed before, x digest, and you will see something like this. If you want to make sure your hash has a password properly, you can use pbkey df2 underscore HMAC, a key derivation algorithm that allows you to specify a salt and also the number of iterations used by the algorithm itself. As computers get more and more powerful, it's important to increase the amount of iteration we do over time. Otherwise, the likelihood of successful brute force attack on our data increases as time passes. Here, here's how you would use such as algorithms. For this exercise, you will import OS. Then, let's say the key it's hashlib dot pvk df2 underscore HMAC. I will say SHA 256, my password 123, os dot random 16 and 100,000. Okay, the key dot x, like this. Notice here that the method always will random to provide 16 bytes random salt as recommended by the recommendation. I encourage you to explore the experiment with this module, as sooner or later you have to use it.